Now, preparing a model for printing can be tricky, right? When you're 3D printing, your number one enemy is gravity. And unlike paper, we can't just, press Control P and send this object to print, right? I mean, technically we could, but what we're going to notice is that there are going to be some inefficiencies in it. How quick you print is going to be largely based on how you organize your model for printing. So that's what we're going to be looking on today. Now, the great thing about 3D printing is that you don't need a physical 3D printer to prepare your model for being printed, right? So for example, you might know a company or somebody with a 3D printer. You don't have to have the 3D printer to prepare your model. Now, all 3D printers use a program what's called a slicer, and there are many different versions of this type of program. The slicer is an application that works with FDM printers, right? And as the name suggests, it slices your model in and prepares it so that when the printer gets it, it will be able to print. So if you plan to print models, especially models that are architectural models, geometric models, you're going to want to prepare those 3D models using the slicer to determine if the model is appropriate for printing. In order to get a 3D slicer application, you can download them. They're all free. The one we're using today is going to be from Bambu Labs. So if you just Google Bambu Studio, that's the name of the program, you will see it here. So if you plan to do any kind of 3D printing using an FMD printer, you can use pretty much any slicing program to check your model to ensure that it will print in a reasonable time and that there are no errors with the model, right? So for this particular case, we're going to be using the Bambu Slicer, and we can just download that from the website. All right. Now, when you open the program, this is pretty much what you're going to see. We're going to choose Getting Started. You're going to choose your area. We're just going to choose North America for this. And you can skip this, and you're going to choose your printer. Now, remember what I said. Even if you don't have a Bambu printer or any 3D printer, it doesn't matter. You can still use this program to check your model and see how long it would take to print, right? In this case, I do have a 3D printer here, right? So I'm going to uncheck these and only leave the one check that I have, which is the Bambu Lab P1S. That's the one I have. All right. And I'm going to choose next. And it's going to ask me for the filament selection. This part doesn't really matter. I'm going to just leave everything at default. Filament is what your printer uses to print, right? Usually comes on a spool. And this is just asking you what types of filament are you going to print with, so you can create a profile for them. So we're going to leave everything at default. And this is asking to install the network plugin. If you do have a printer there, you would want to install this plugin. It allows you to connect to your computer, to their printer wirelessly or through the internet. So in this case, I'm going to leave this checked and choose finish because I do have a printer on my network in this case. All right. And that's it. We're all done. And that's all we needed to do. Now, this is telling me that there's a new version. There's usually new versions that come out pretty often, so that's okay. I'm not going to upgrade right now. Right now, we want to take a look on our model that's here and see how it translates to the 3D printing software. Okay, now I'm going to sign in because I do have a login. So it has all of my settings and filaments and profiles already linked with my login. So in this case, I'm going to log in. Now you don't need to log in if you don't want to. It's up to you. You can create an account that's free so that when you install Bambu Labs on a different computer, you can just log in and all your settings will just translate beautifully. Now that I'm logged in, it is asking me if I want to sync all of my data. I'm going to say yes. And now it will load all of my settings. Okay, so when you are using a slicer, in this case, the Bambo slicer, these headings are what we need to pay attention to, right? So first we prepare, then we preview, then we basically select our device and print. So they're kind of in the order that you would proceed through, right? So let's go to prepare. All right, now, well, firstly, I'm a big fan of dark mode. So if you are as well, you would want to go into your properties and you'd want to go to enable dark mode. Yes, now I feel right at home. Anyway, so this is the program, and this here is representing the print bed. So this is where your model will be printed on, right? So what we're going to need to do is to import the model. And if you notice here, we can import STL or OBJ. In this case, we're going to be using OBJ. So we're going to need to export this model here as an OBJ file so we can open it over here. So we're going to go to File, Export, and we're just going to save it to the desktop, and we're going to call this Serpot. And we're going to save it as an OBJ export. So we're going to be looking for OBJ. Here it is. And we're going to choose Save. Now it's going to ask us a bunch of questions. For the most part, we can leave all of this default, and we're going to choose Export. Now over in our 3D program, we're going to go to File, and we're going to go to Import, and we're going to go to the desktop. And now it's going to say file contains polygons with more than 4 vertices. That is simply saying that there are areas in this model that are n-gons, right? Which simply mean a polygon has 3 sides, a quad has 4 sides, and let's just say an n-gon mean that it has more than 4 sides, which might cause compatibility issues. That's why it's giving us this error here. So we would need to fix that. And this is why usually sometimes with models, there's normally a preparation procedure that you have to go through before printing. This one won't even import because there are just polygons that are just not compatible with the way that the slicer works. Now, in my case, what I need to do is I need to go back to my export options. So I'm going to export this again. And I want to change this I'm going to change this to triangles. And I'm going to uncheck export materials and library because I don't need materials. And also the scale, if you notice, by default, the scale is going to be 1. And if the scale is 1:1, well, in 3ds Max, my scale is centimeters, but in the slicer, my scale is millimeters. So that would mean I need to multiply this by 10 to make my scale be correct. Now, also, if I'm coming from 3ds Max, I'm going to uncheck flip Y and Z axis because the model is going to come on the side. So when I uncheck this, the model will come facing the same way that it is here. So I'm going to choose export, and then I'm going to go to the slicer and choose import again. And there we go. So this is the actual model. Now notice that we do have some errors like here. And as a matter of fact, if you look down the bottom, it will tell you that there are some errors that needs to be repaired. So you can click the repair button. And if you notice, it fixed those errors nicely. So this is what it looks like. Now we can go to preview, and it will preview the slicing process. And if you see here, this is saying it's going to take a whopping 15 hours to print this model exactly like how it is, coming directly out of the software and into the slicer. So 15 hours is a very long time. And not only does it take 15 hours, but like all of these blue areas, if you look at them, the blue corresponds to the blue here, and it's called overhangs. So walls that are overhangs are going to give you trouble. It's going to cause issues with printing. Basically, you should avoid this at all costs. Now, also based on this model, I can see that about 50% of the model is used to print what you call sparse infill. So sparse infill is, if I should adjust the slicer here, and if you look here, the slicer has these elements here and here. Most slicers have them. There might be different icons, but they usually have these. And what you can do is carry this down to see the different layers that makes up this print. So you can see it's going down and down. And this red area here, which is the infill, is what is referred to as the sparse infill, right? So this is this, and this takes about 7 hours with this print. So pretty much this is what takes up most of the time, because the printer has to print all of this infill during the print. Now, there are some things that we can do to make this a bit more efficient, right? Because, you know, creating all of this infill is quite an overkill and it takes a lot of time. But we're going to look at how we can optimize this model in a little bit. Now, the other main challenge with printing this is, of course, because of these blue areas, because these blue areas means that the model is essentially floating, right? So I will need to go back here, and I think let's make sure that the model is on the ground. So we're going to click on it and we're going to move it down just a little bit, down on the blue axis. There we go. So now it's not floating anymore. It was floating a while ago. All right, let's go back to preview. Good. So good. So so it's not floating. Please reorient the object to enable support generation. Now this blue area, this is what it's telling you that, look, you can't print this up, or you can, but you're going to experience more than likely print failure with trying to print this large overhang here, because the printer cannot just print this in mid-air. If I carry the slicer down here and you zoom into this edge right here and I show you what the printer is doing, so this area here shows you what is being printed exactly as how the print head is going to print. So notice it prints that, then it prints that, then it prints that. But this first area that it printed, if you notice, this blue area that's printed here is literally printed in thin air. Like it's just going to fall, literally. So this is the issue with this printer, with this particular model. Now, if I wanted to print this as is, I would have to go into, in this case, remember all of the different slicers are a little different. I would need to go to support, and I will need to enable support. And I would choose tree support auto. And this is going to take a while to preview. If you notice, you see the slicing is taking a while. And now you can see where it generated all of these supports to help where the blue areas are, because what's happening is that in order to print this, it has to be supported. You can see them there. And of course, all of this, it's taking a whopping 22 hours to print. So this is why if we're going to print something, we can't necessarily just send it straight to the slicer to print. We really need to prepare that model so that we can get some smaller times. Now, one way we could try to split this model is, let's say we print everything above this line. So that's all of this part here as one, and then print everything below this line as another, and then the base. Then we print this piece here. So therefore we have 1, 2, 3, 4 parts. That could be one approach, but also we know that in terms of materials, we want the column to be a different material. So this would have to be 5. And we also want these elements to be a different material. So let's look at a different area. Let's try to take it from this point of view here. We could try to get this part here as one print, then the outer sections as another print. So that way we can get the, between 1 and 2 to be 2 different colors. So that also is an approach that we can use. So now we're going to have to start to split this up. Now we could use subtractions to split this element up, but that may prove tricky. Let's see. Now, as we go deeper into the preparation of the 3D model for print, I'm going to do less step-by-step instructions, and it's going to be more of just a time lapse of how I prepared the model. We're going to detach this section here. We got to detach the inside as well. And we have these little strips that we need to get rid of. Now we need to figure out this part, because this needs to be completely flat. So let's figure out here first. This has an extra edge. There we go. that should be like that. Okay, so would be good if all of this part was we're just gonna cut this, but we're gonna just use the imprint option. So that way we get a marking and then we can manually, we can cap it. Right, great. Now we need to figure out the rest of this area here. Perpendicular, we're gonna have to do Shift X, I think. There we go. So that way it keeps moving perpendicular. Parallel. So notice that it's moving parallel on this edge. Good. So we know that this height is the same height here, and that's the same height here, and the same height up here. Maybe I can just grab this here. We'll fix that in a bit. First, we need to fix here. Who wants to have an illegal face? Okay, all right, fine. Let's do something else. So this can come out like this. I know this is going to be a little tricky. That's so this part is all right, but this part is not all right. Okay. I'm not sure about this part here. Let's see. Do the Shift X and move this up. Yep. Yes, I can. Okay, they're not huge issues. All right, so I think the final part of this is to work out this horizontal piece here and how we're gonna let this 3D printed piece come in. All right, now this is gonna be a little tricky. I think, yeah, I think that we should slice everything up to this point here. All right, now that we have all of this done, now let's see how it performs in our software. So remember, the last time we just tried to print the model directly, we got 22-hour print time. So we're actually going to save this. All right, so now we're going to open a new file. There we go. And we're also going to choose different colors for our print as well. So, but before we do that, let's import all the different parts. 1, 2, 3, 4, 5, 6, 7. We don't want it to be a single object. We want it to be different objects. All right, now of course, everything is jumbled. They are the correct scale. So we're going to have to put additional plates here because everything can't fit on one plate. So yeah, we're going to have to see the best way that we can print these. And some of them has errors like this. We're going to have to repair. Yep, which is fine. And it's giving us an error message telling us that the base here, we have some elements that are outside the base. So like these are outside, but that's okay. We're going to fix that soon. All right. So this can be one part here. Then maybe we can print that along with this and this. Trying to see if we can fit everything. Okay, so this is going to have to be flat. This one is tricky because we have this step right here, right, which is the cutout for this. I'm thinking maybe we could print all of this as one piece, but we did want this as a different color. That's the problem. So if we try to put this flat like that, we're going to end up with this piece here. So we would have to add support for here, which we can do. That's not an issue. The support would be very small, so it's a minor price to pay. We need to repair this. All right, so we could totally just support this end here and print this because we want to have this as a different color. So I'm going to put this to flat. The question is, can everything fit? Okay, maybe we could print this over here. All right, I think we got it. Yep. Oh, of course. Then there's the issue of color, right? So everything that's going to be different colors, we're going to have to print it on a different plate. So all of this is going to be one color. Let's take a look back on our model and we can actually color it from here, right? So we have black, gray, and white. So I'm thinking this area here could be white. Then maybe this could be black. Let's make it so that represents black. It's not exactly black, but let's make it darker. This here could be that gray color. Then this could definitely be black. We do have, let me see, we have some orange actually. So I'm thinking we could make this one be orange. This also be orange. And this could be, let's make it orange too. And this base, let's make the base black. So this would be what the print would look like. I think that's pretty interesting. I like the way how the orange continues across the horizontal area here, the cantilever. Let's see, what if we made this white? The white is okay, but I definitely think the column works better in orange in this zone right here. So it looks like the orange is kind of bleeding and going up like that. And the white is on top. And then we have the base, which is this gray. All right. So if that's going to be the case, then we're going to need 4 plates. So 1 for each color. Based on what we have here, this is going to be gray, and that's pretty much the only gray. This is going to be orange, and the column is going to be orange. And then this is going to be black, and the base is going to be black. I hope these can fit. These are pretty tight. They should be fine. Yep. And this is going to be orange as well. So we need to move this over here. And this is the only thing that's white. So we have gray and white, black and orange, according to our color code in here. All right. Now, let's see. Now we could print this, or we could put this. We're going to have to put this flat, definitely, like that. This, I'm thinking to print it upside down so it can print all the way up. I normally try to bundle my prints close because there's less travel with the print head, so it will reduce your print time. And also it helps with stability because when it's printing the base that it creates, it bleeds into the other base and makes everything more stable. This is pretty much going to be one big print. And this guy here is going to be needing supports. So we're going to do that. All right, let's save this file. And we're going to call this one block planter pot. And then we're going to say prepared print. All right, let's see what the print time looks like. Okay, for this one, we're going to need support. So let us deal with this support. So we're going to go to support and we're going to say tree auto, and style we're going to say organic. Then we're going to, well, let's save and then let's preview the slice. So this is generating the first slice. Remember, this one is hollow inside. This one needed a little support here actually. Okay, what about inside? Yep, inside is going to need supports because it's hollow. And this one here is 9 hours. I think we can do better with this one because it has to print these supports inside. So that's pretty much just like printing the infill, I think. So we're going to have to figure out a better way for that print. What about this one? So this one needs support below. This is 7 hours to print. It needs support for these areas here. Let me see, 7 hours, 3 hours is infill. So we could, let's look at the strength and infill density. Let's put this to like 5%. Okay, now it's 4 hours. I think this one is the best that we can do, but we can do something else for here. So we can probably make this a bit better. Let's look at this one. This one is 2 hours. It's not that bad. The sparse infill, the greatest one, and it's 5%. So I don't think we can do anything else to this one. So 2 hours seems to be it. And this one is 3 hours. Of course, it has the infill. There's this weird error that it has here. Actually, I think it's because of a polygon error. So I need to look into that here. So for 3 hours, I guess this is okay, but we need to correct a polygon error here. All right, so let's see if we can get these problems fixed. Now, the first issue we have is that this takes 7 hours, which is this piece here. Now, it did cut down the time because we made inside hollow, but I'm thinking of an idea here where we could possibly, yeah, okay. Let's remove the shell that we had before and convert this to an editable poly. Let us auto smooth. And what I'm thinking of doing is to get rid of all of these supports on the inside, I would need to get rid of this top base here. So if we could have the top base printed separately where we can just fit it on top rather than having to print supports, we may be able to save ourselves there. Then this support that's here, we could get around it by making it taper, but that might be an issue because remember we need to fit the piece under this. So we're probably going to have to go with this support, but we can get rid of these. Now to do that, we're going to have to do some more cutting. So let me see, from the top view, I'm going to create a box. Convert this to editable poly. Let's create the box flat on the ground. There we go. Let's convert this to editable poly. I can't see these lines because they're black. I think I need to change the background of Max. Let's try. Okay, yeah, that's good. I have to put this up to here. All right, so we're gonna subtract all of this space outside this box here, right? Then we're gonna do the same thing again for here. This is gonna be the top part. Well, actually, no, let's leave the top part. Let's just make the top part a sparse infill. And I think we should be okay with that. Now for this to work, I'm gonna copy this and I'm gonna select the top parts here, delete that. So I've created a flat face here. I think that's what I need to do. And then for here, I need to now go ahead and do a pro boolean and a subtraction. So this should now have a hole in it, like this. That's cool. Then we have the top part here. And what we want to do now is here, connect somewhere up here and move this piece inside. All right, so you can see clearly that this is the inside that we're cutting. Okay, good. Now we need to cut this again. We're gonna do a subtraction. So now we have this empty. Based on how this is, if I hide this here, if I end isolation, we actually don't need this to be, yeah, we can actually use this as just a hollow area because it's going to be covered with this. So we're not going to see it. And this is going to be below. So we should be fine just like this. So I'm going to save this and I'm going to export this and I'm going to call this lower side base object. Now, the great thing about the Bambu software is that we can just update this element here. So we can just right click and say reload from disk. And there we go. This is now updated. So now we can preview this again and we're down to 4 hours. Wow. So we have reduced this by about 3 hours by just doing this hollow section here. I mean, maybe we could even do more. We could actually cut more into this section, I think. Let me see. Actually, we can't because we need this thick area here. So I think that's all we can do for this one. So it's going to have to be 4 hours. Now, for this one, I think we can save ourselves some time with these window areas here. Actually, if we taper them, so select these here, and we're just going to taper them like that. Now we're going to export this again. Export selected and upper planter box. And then we're going to go back here and right click and say reload from disk. So now you can see it's tapered. We're going to do the repair and let's slice. And we are 4 hours. Not bad. And we didn't have to get the supports for here because we made it taper. Now we still do need these supports. So that's okay. And supports, we spent 28 minutes on supports. That's only 10% of the print. Most of the time is spent on the sparse infill, which is all of this stuff here. But in this case, we do need it and we already cut it down to 5%. So it's pretty low actually. All right, let's go to our next one. All right, I believe these guys were okay at 2 hours of print. Yeah, those were okay. I think maybe we could make them a little tighter though. So I'm gonna rotate this like that. Then I'm gonna rotate this. Now I also notice this little thing is sticking out right here, but when you slice it, it doesn't get picked up on the slice because it's so small. So I think we can just ignore that little piece right there for now. And this guy here, we're going to put it in the middle. Let me see. I'm putting it in the middle because it will really help with the print time because the printer doesn't have to travel that far. Let me try it right here. And you can notice that all of the base are kind of tied in, which is good, I think. It will help to keep everything stable. All right, good. I think this one is fine now. Let me make sure to save. And for our last piece here, I don't think that, oh, we need to fix this little issue here with the polygon. So let's go back over to Max. Let's take a look on our base. We seem to be getting an issue here. Auto smooth. I'm going to put in some more cuts. Let me put in a cut like that. I think that, hopefully, let me put in another cut from here to here. Okay, I think that should hopefully solve it. Let's see. So, and I think the problem is these guys here. Yeah, you can see this comes up and that's what's causing the issue. Okay, we could just eyeball it. And slice. There we go. Nice and flat. All right. And that part there is 3 hours. All right. So I do believe we are ready to now choose our color options and then we start printing. All right. Now what we want to do is see what our total time adds up to. Yep. So our total time is 14 hours. So now it's time to print. Now, one thing that I do realize is that I don't have any orange. I have green. So we are going to revise our plan, and where we had orange, it would now be green. So that's kind of like what everything is looking like, which is nice. The green will match with the actual plant. So these will be green, these will be black. So if we go to objects here, we do have an error here we need to repair. There we go. Okay, there we go. Make sure that these are all flat. All right, so now we need to add the color. So this is going to be white, green, and this one is going to be black. For these elements here, we are going to make them green. For the base and the cantilever, we're going to make it black. And for the main side base, we're going to make that gray. And then the top is going to be white. So these are the colors that we are going to use to print. Now we can actually see the process of printing. So this is actually a camera, so we can see inside the printer. And now the bed is preheating in order to start the printing process. So let the printing begin. More like let the waiting begin. Okay, so we're going to put these together and we have all of these pieces here, right? They look pretty decent. We have some that were just printed. So we can see we need to remove these. So we're going to do that now. Whew. Now that was a long tutorial. If this content was useful to you, don't forget to leave a like. Also, you can comment and tell me the type of 3D models that you would like to see done in the future on this channel, because I have plans to do much more elaborate architectural 3D printing models, so you can tell me what you think about this content. So, until next time, I'll see you in the next one.